Welcome back. Let's try to do one more example with joins. We are trying to list now all the movies where Brad Pitt was playing. How can we answer this query? What do we need to do first? First, we need to find Brad Pitt. Where is Brad Pitt? Well, we have this information in the actors table, so let's go and write our query. Select star from actors, where first name is equal to Brad and last name is equal to Pitt. We execute now this query and we find the entry for Brad Pitt. Next, we want to find the movies that he's played. Of course, if you take a look at the entity relationship diagram, you will see that the actors table is only connected to movies through roles. So, in order to execute our join, we're going to join first the actors table with the roles table and find the roles in which Brad Pitt was playing. We modify now our query by adding the following: inner join roles R on r.actor_id is equal to a.id. This query, if you execute it, you'll see that it gives us back the movie IDs and all the roles that Brad Pitt has played. As you can see from the results, a few of the roles are kind of fake because we see that he's playing himself. So for example, here he is red carpet presenter and so on. Let's try to get rid of the movies where he's playing himself. First, let's try this inequality condition where r.role different than himself. We haven't eliminated many roles, but still there are quite a few movies where he's still playing himself. Why do we also get back these roles? Well, because the role attribute is not exactly himself, so the strict inequality doesn't really work. How can we deal with that? If you remember, we used the like operator in the past to do approximate matches. We're going to do the same thing here. We're going to use the like operator to avoid all these roles where Brad Pitt is playing himself. What we're going to do now is we're going to specify that and r.role not like himself, and we're going to put percentile before and after himself. Notice the condition. In that case, we have not like. We have studied like before. Not like says, if it matches this pattern, don't return it back. So pretty easy, like, not like. Notice now that we don't get back any roles where the string himself appears anywhere in the role. And in that case, we have avoided getting back the roles that we don't need. Let's continue with our query now. We have the roles, but we don't have the details for the movie. We just have the movie ID. How can we add the details for the movies? We need to expand our query by adding the movies table. So we go in the from part and we add inner join movies m on m.id equal to r.movieid. Execute now the query and you'll see that we have the results. We have quite a few columns. Now let's try to clean up the columns because we don't really need all the data that is showing up. We'll keep only title, rating, year, and role from the movie. So we go and we modify the select statement as follows. Select m.name as title, m.rank as rating, m.year as release year, and r.role. So we have the results, only the columns that we need. Now finally, let's try to rank the movies, putting on top the movies with the highest rating. So how can we rank? We go at the end of the query, order by m.rank, and then descending because we want the top movies at the very top. So you can see that Fight Club, released in 1999, is the best rated movie for Brad Pitt, where he's playing Tyler Durden, and then followed by Seven, released in 1995 with a rating of 8.4. He's playing Detective David Mills. Then 12 Monkeys with a rating of 7.9, 95, where he's playing Jeffrey Goins, and so on. So I hope that these example queries with joins gave you an idea of how we approach the process of writing such queries. In our next video, we'll examine a few additional examples using the Facebook database, mainly to give you some extra practice on how to navigate an entity relationship diagram and find the right tables for the joins. So, until then, play around and practice. See you next time.